Good morning, everybody, and welcome to our fireside chat here for Invest in Software Quality to Avoid a Meltdown. As we all know, there was a couple meltdowns over the holidays, and so Gloria and I today are going to be talking a little bit about that and just kind of in a back and forth um, kind of Q&A. With that, I want to let everybody know as we're going through this, we're going to be monitoring the questions. And so please feel free to ask questions during this, and we will try to address those questions during the talk. So other than that, couple of house cleaning notes. We'll leave a little bit of time at the end too if you wanted to ask some questions at the end. And if you have any problems with things rendering, we're not going to be showing a bunch of slides today. Most of this is going to be just a back and forth conversation with Gregory and I. So feel free to hold the questions until the end or ask them during our talk. So my name is Adam Atanasio. I'm a product manager here at Parasoft. I handle the functional products division. And on with me today, I've got one of our solutions engineers, Gregory. Good morning, Gregory. How are you?
Good morning, Adam. Thank you for having me.
Yeah,
Doing well.
great. So this morning I want to talk about, so you recently wrote a blog for 4 continuous testing strategies and how to avoid a meltdown. So I want to talk about that a little bit today. And I know that one of the big topics that you address in this is why peak season is so important and why testing before peak season is such a huge thing. You want to touch on that for a little bit?
Yeah, absolutely. So the uh, the blog was kind of a manifestation. It was really kind of what was happening during the holiday seasons this year's, and really what happens kind of every year, right? Every time we get into peak season, it seems like there's chaos, there's unforeseen circumstances, and that really affects our day-to-day lives. But it
Hmm.
also really affects businesses, and it affects companies that really rely on peak season to be, uh, you know, the most profitable time of the year for them. And that's really why peak season is so important. And if you think about it in a sort of a smaller analogy, right? If you're working at a deli, you're pretty much planning your day around that lunchtime craziness, right? At lunchtime, everybody's out, of the offices, out of schools, etc., grabbing sandwiches, whatever it is. You purchase enough supplies, you purchase enough produce to
Right?
to make sure that people to make sure that you can serve at that time, right? And you want to stay open during that time. Well, that's really peak season for a lot of technology companies, retail companies, travel companies, etc. Is that's what they want to prepare for. The challenge there is, if you're running a deli, you pretty much know your customers at that point, right? You got
Right.
most of the same folks coming in. You kind of have a good idea of what's going to happen. But um, when you look at what's been happening over the last few years, we're seeing significant increases in capacity right around
Hmm.
peak season, and what companies have to prepare themselves for. So, as an example, if you look at a report by Salesforce in 2020, uh, retail companies saw and digital revenue companies saw an increase of 25 to 50% year over year. So that is
Wow.
that's significant, and that's something that you not only have to prepare for. Okay, we're going to have way more people than last year. First of all, we're going to have way more people than yesterday, but we're also going to have way more people than last year. But we also don't really know how many more people, because if you look at a year like 2020, a bunch of things happen, right? So it's not to say that 2021 saw the same increase, but it did see an increase. It's not to say that that's going to continue, but nowadays you really don't know what's going to happen, and our previous holiday season is exactly a manifestation of that. Now, the other
Okay.
key thing here is during peak season is where your company really manifests its reputation and maintains its customer loyalty, right? So if you do a fantastic job during peak season, if you are able to provide your customers with a good customer experience during perceivably difficult times, that's going to gain you brand recognition. That's going to gain loyal customers. On the other hand, if your customers have a bad experience, there's
Yeah.
over a 50% chance at that point that you are potentially losing that customer, and that customer may go to a competitor. So peak season, really make it, make or break for for technology companies or retail companies, travel companies, right? And they have to be prepared. And to do that, you have to invest. And
Right.
that's what we're going to talk about today.
Great. Great. No, I'm looking forward to it. So, you touched on a couple points there. One of them is customer loyalty, and customer loyalty is so important, especially during those peak periods of time, because that's really where you can do the most damage to the reputation. And one of the things that does that, and I'm going to bring up another slide here just to kind of talk a little bit going through. Let's talk a little bit about performance testing, because this is really one of the big avenues that doesn't get tested during this time frame. And so, with performance testing, we've also got modernization of those processes. So, with this, what happened here over the holidays, one of the things that I don't think was managed well was making sure to test for that type of performance when that perfect storm hits. And from a revenue standpoint, sometimes companies don't think about going in and doing that, because it would often mean a forklift upgrade where they have to go in basically with a forklift, rip everything out, and start fresh. So, um, what are what are some of your ideas of what modernization means uh, in the realm of performance testing?
Yeah. So great question. So let's kind of take a step back for a second, and think about what we mean when we talk about modernization in the first place, right? So from a uh, peak season perspective, right? Handling the peak season means modernizing technology, not just in the peak season, but actually modernizing your technology year round. You have to continue to do that. You have to invest in that type of activity all year round, and you have to prepare for those unknown unknowns that you can expect during the peak season. And that can be a number of things. That could be updating hardware and software.
Mhm.
So just straight up upgrading your servers, computers, other hardware to newer models, and increase those performance capabilities based on that. Uh, that could also mean adopting new technologies, right? So now we're very actively talking about technologies like artificial intelligence, blockchain, cloud computing to improve efficiency, and really to stay competitive
Right.
with other brands in the same industry. And of course, that all leads to enhancing the user experience, right? So you don't want the user experience to stay stagnant from year after year. You do want to continue enhancing that user experience. You want to offer something that the competitors don't. So the thing that I think we want to focus on specifically is the adopting new technologies component. And if you look at peak season and you look at organizations and companies that are able to effectively manage those scenarios, more often than not, they're adopting some form of cloud computing because it really enables them to scale on demand. And it also shifts the burden from the organization, from a cost perspective of maintaining physical hardware, having teams dedicated to maintaining that physical hardware, to cloud providers who can actually scale up and scale down on demand, right? And not only that, you're also actually saving costs because you're only paying for what you need. Now, granted, during the peak season, you need everything, right? You need as much as you can get. But at other times, that may not be the case, and that's actually going to reduce costs altogether. Now, to
Sure.
your point about a forklift upgrade, how do you get there, right? You can't just rip out legacy systems. You can't just rip out on-prem hardware and say, okay, we're putting everything into the cloud, because um, from that perspective, you now have to um, you really have to do all your testing all at once, right? You replace You test, and then now what do I do, right? Fixing that is going to be
Right.
very costly, very difficult, and the feedback back to developers is going to be a problem as well. So this is where we get into the performance testing of things. And you as an organization, you're always going to do performance testing. You're always going to do your traditional performance test where you're really looking at the system's behavior and focusing on things like speed and reliability. But to aid in a gradual or incremental upgrade of your systems, you also want to incorporate a practice which is continuous load testing. So in load testing, you're paying more particular attention to how a system behaves when multiple users are using at the same time, and when you're doing it continuously, you're actually monitoring that system's health over time as you're making these incremental upgrades. This is going to help you mitigate risk when it comes down
Hmm.
to implementing those upgrades. It's also going to give faster feedback to developers when something does seem off immediately, right? So
Right.
avoid a
Right.
forklift upgrade and implement continuous load testing. Now, what is the challenge of implementing continuous load testing? Why don't we just, do it all the time? Well, one of
Uh,
the.
I no, I was gonna kind of uh, go off of that and talk about or ask about some of those challenges, and some of those challenges I'm sure is in the past a lot of those processes have been manual, um, where you had to either spin up a live machine or spin up bare metal to test load and do things like that. So what are some of the strategies for automation on that?
Yeah, so that's definitely a challenge. Additionally, when you consider, let's say what happened, let's say if you consider some of the most recent events, there is an inherent complexity to creating a realistic test scenario, right? A
Hmm.
realistic performance test scenario, because our systems are complex, especially if you look at you know uh, retail management systems, and travel management systems, and things like that. There's so many different components. There's so many different moving pieces that you have to you really have to create test data that fits that fits the complexity of that scenario. And so test data is a big challenge there. With continuous load testing, the challenge there is you're kind of shifting the responsibility in your organization of defining those those load tests, right? Typically, you have a dedicated performance team that's going to take on the challenge of doing adequate performance testing and kind of running those tests more or less when the system is ready for that type of testing. With continuous load testing, it's really your test automation engineers that now need to sort of take some of that responsibility and really convert some of those tests into something that they can run as a part of a development pipeline. And from that perspective, you have to look at solutions. You have to look at tools that allow you to do that, right? If you've already defined a set of regression tests, functional tests, etc., what are some of those tests that you can already reuse, especially when we talk about various scenarios, right? You're already testing for those scenarios at a sort of a smaller uh, individual level, but can you take
Hmm.
that now? Can you create a sort of a mix of users or a mix of conditions, a perfect storm, if you will, to validate your system's behavior time over time with every single release, with every single incremental upgrade, right? And that's
Right.
really where that continuous load testing practice comes in.
Now, we hear out there all the time, shift left, and performance testing is definitely one of those categories that fits into the shift left um, side of it, right? Moving moving as much as you can, figuring out, automating everything that you can to get that to find where problems are going to be before they happen is really what the big focus is. Um, so with that, we've talked about some of the load testing and the performance testing, and definitely one of the areas that we work with in there is service virtualization and test data. So let's talk a little bit about virtualization here in the second area that we'll talk about. Um, And what are some of the problems with either trying to use production data or uh, production servers and things like that? Where does service virtualization come into this practice of continuous testing and helping to avoid that meltdown?
Absolutely. So, for when we think about service virtualization, a lot of times we think about specifically testing practices. But just to be clear, service virtualization um, is a strategy that can be implemented in the development stages. It can also be implemented in the operational stages of your business, and we can talk about some of those examples in a little bit. But from a testing perspective, what you're typically looking at is you're typically looking at your environment, right? You're looking at stabilizing your test environments, and when you think about uh, the the components in that system, you're always going to have those components that are a bit shaky, right? They're either shaky due to availability.
Hmm.
They might not be available because they are developed on a different schedule, right? Or it's just being managed by another team, or it's undergoing one of those incremental upgrades. It could be in a certain state, right? So, from a behavior perspective, it might not be in a state where your test data is applicable or it's relevant, and that can present challenges for that particular test environment. You have to then go back and make sure that all these components in the right state. There's
Right.
usually a cost associated with maintenance of these test environments, and that's a lot of times due to the fact that you're working with third-party systems, or you're integrating with third-party systems that, although they do provide some sort of sandbox environment that you can do regression testing in, or some functional validation, you may not necessarily be able to do something like performance testing or continuous load testing, because
Sure.
the costs there could prove to be prohibitive. And then finally, data, right? So again, we talk about test data, and anytime you talk about data, we all know that production data is really the best data, right? Or at least
Right.
we assume that it's the best data because it's going to give us the most realistic. Uh, it, 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 um, it's going to give us the most realistic version of how our customers use our applications. But data is expensive, right?
A-
Especially
And
production data.
and compliance. Compliance is a big factor when you're dealing with that data, right? The
Hmm.
the personal identifiable information, for example, is something you don't necessarily want to test with live PII. You want to be able to mix that up. So
Right. And the title of today's talk is, invest in software quality. So on one hand, yeah, absolutely, yes, it's expensive, but you have to invest in software quality. But you also have to invest in a sort of a strategic way. And when you look at service virtualization can help you address all of those things, whether it's availability, whether it's behavior, whether it's cost, or data. Now, specifically when we talk about peak season, specifically when we talk about preparing ourselves for these scenarios, we have to look at the test data problem. And
mhm,
the going back to production data, it's expensive. It's expensive to scrub that data. It's expensive to manage uh, data lakes, to manage test data databases, and continuously iterate on that data and make sure that it's up to date, because production data does have an expiration date. Especially when you look at something like the travel industry, you have to it's so date focused. It's so important to have test data with the right times, with the right schedules, with the right everything that matches up, in
sure.
order for all those interdependent systems to work together. And I uh, keep going back to this, but there are um, we've done extensive talks with our customers in the airline industry about how they use service virtualization to solve some of those challenges. But to sort of sum it up, there's a few things that service virtualization can do to solve the test data challenge. Number one, it's going to reduce the need for large volumes of test data, right? So
Mhm.
when you're using virtual versions of your dependent systems, or those components, that enables you to test systems or applications with smaller volumes of data. You can isolate components. You can repeat certain flows, certain scenarios with the same data, because at the end of the day, your virtual services are defined in a way that you need them to behave in that particular scenario. So that does allow you to subset that data. It allows you to test with smaller sets of data. It also protects data privacy, right? So you talked about
Sure.
compliance. Service virtualization allows you to use fake data, made up data, generate data, or create data based on a model of some sort that you define in order to create realistic scenarios. It simplifies your data complexity, right? So with virtual assets, you can really simplify that test data and focus on the testing, let's say the performance of your system or your
Hmm.
application or a specific flow or a specific feature, right? Improves data maintenance. So, you know, again, updating that data is much easier. It's not production data. You don't have to go back into your production environment and reload the data, scrub the data, subset data, make sure that the data fits into the parameters that you need it to fit into, and it actually reduces your storage requirements, right? So you don't necessarily
Right.
need to have that data in a single place. So from that perspective, service virtualization is a very flexible solution, and that flexibility really reduces the requirements associated with large, expensive, complex test data.
Gotcha. So I had a question come in here, um, asking about, excuse me, how how to convince leadership to invest. I know that kind of that's kind of a big question because that comes up quite a bit when you're dealing with practitioners and different folks, whether it's the QA team or the devs, talking about, hey, there's some things coming up, and leadership's always going to be like, well, that costs a lot of money. So how do we justify that? So what are your thoughts on some of the ways to help convince leadership? I think that's a great question, by the way. Thank you for asking that.
Yeah, absolutely. Great question. Now, hopefully, hopefully you don't have to convince leadership to invest in software quality, but typically you do. And the you know the way to do that is number one, you have to explain the benefits, right? So you have to help leadership understand the benefits of investing in software quality. Uh, you have to identify customer satisfaction as a key component of your business model. You have to identify the reduced cost of rework, the cost of you know of risk, the cost of security breaches, and frankly, historically speaking, there's good evidence and there's good data to show that when you don't invest in the risks are great and you do miss the mark, especially during peak season, that obviously costs a lot of money. Now, to that point, use the data, right? Use data to show the impact of poor software quality, show how much it actually costs to fix bugs, show how much it
Hmm.
costs to test legacy systems, show that frankly getting appropriate test coverage and code coverage and quality practices onto legacy systems is a very difficult task. I mean, we can go back and forth on definition of legacy systems, but in a general sense, legacy systems are untested systems or undocumented
Right.
systems that don't have apt testing associated with it, right? So
Sure.
um, by highlighting that, the best thing we can do is really just test the changes. We are leaving a lot of risk on the table still. And then of course there's industry best practices. So you can leverage things that are already de facto standards in the industry, whether it's ISO standards or capability maturity models or things like your CWEs and OWASPs and so on and so forth, right? This can kind of bring additional authority to your overall thesis, which is that without investing in software quality, we're not going to be able to meet these standards. We're not going to be able
Right.
to uh, benefit from actually adhering to these standards, and therefore we are exposing ourselves to additional risk. And I can't emphasize this enough. you have to start from the customer experience perspective, right? If your customers are having a bad
Absolutely.
experience, you're going to lose the customer, you're going to lose the revenue from that customer. So um, if you don't invest, you're losing money. That's the big picture, but breaking that down into individual components, you have to use the tools that are available to do that.
Right. And a meltdown like we saw that this holiday season that affected a lot of customers. So it had a very interesting effect kind of
It
across the board.
also affected a lot of competitors because they now have new customers.
And kind of on the side note, it affected a lot of non-customers because people couldn't get where they were supposed to be going and spending the holidays. So it kind of spreads out beyond just the one customer that's in front of you at that time. I mean, it can get quite deep into there. So um, that actually is a perfect segue into kind of the next topic that I wanted to talk about, which is chaos engineering. So um, you know, chaos engineering, can that be considered as a form of fault testing? And kind of how would you describe chaos engineering to someone who is looking at it kind of for the first time?
Yeah, so chaos engineering is absolutely a form of fault testing. Chaos engineering really revolves around intentionally introducing controlled failures and disruptions in your system. And what you're looking to do is you're looking to test its resilience and identify potential weaknesses. In layman terms, you can say what you're looking for is you're looking for the unknown unknown, right? So when we're doing regression testing, we're testing the known known. When we're doing functional testing or UAT, we're kind of testing the known unknown or unknown known. But when we look at the chaos engineering practice, we're really trying to figure out, okay, what did we not consider here, right? And what happens when we experience things that we did not consider before? And so
Hmm.
you define these models. You define sort of a hypothesis about what your potential failures could look like, and you introduce a chaos engineering tool. Now, there's quite a few out there. Probably the most popular one is Chaos Monkey, since it's developed by Netflix, who more or less pioneered this practice. But it really is a top trend, I would say, in 2023. It's been a top trend, and it continues to be a top trend. And um, introducing these types of faults, introducing these conditions into your system can help you identify uh, can help you identify risk in the following sort of areas. Number one is capacity, right? So
Hmm.
systems go down. Can the system continue to handle the increased volume of of the peak season, right? So,
Right.
something doesn't work. Are you going to have to absolutely turn everything off and grab a pencil and paper and uh, try to rescue the season? Um, Ideally, no. Ideally, you've went through that exercise. You've identified where you need to uh, sort of shift your operations in order to continue to uh, serve your customers in a sort of a business as usual type of manner. And actually, that goes back to our conversation about uh, modernizing infrastructure, right? In
Right.
a
Absolutely.
sort of a cloud computing scenario, and when your services are developed in a kind of a serverless approach, right? You have confidence to a high, to a high degree that you're going to um, that you're going to get those additional resources when you need them, right?
Hmm.
If you look at the cloud service providers, they are very well um, equipped to do that. Scale, and that actually brings us to scalability, right? Can your systems scale up and down? So that's the second thing that you're looking for in chaos engineering perspective. Um, then that's, again, that kind of goes back to your infrastructure. If you're on sort of legacy on-prem infrastructure, chances are you've been able to manage for the last few years. But you know what? This year things are different. This
Right.
year, that peak season is even crazier than it was last year. There's some new something else going on in the world, and that completely changes everything for us. So chaos engineering is going to help you identify that, and of course, that all boils down to resilience, right? So
Right.
with all those things considered, can your systems recover quickly enough in order to provide, again, a seamless experience for your customers?
Yeah, it's not the old days anymore. We can just add load balancers and failover to try to make it work. There's so many other systems and so many other dependencies that can fail now.
Absolutely, and then you
So
also have to consider the cost, right? Going back to convincing your leadership, like you have to consider the cost of doing that, and the cost of now being in kind of scramble mode of trying to fix things quickly and do this rework that you really could have been doing the whole time, right? You
right,
could have been doing this all year long, and you could be adhering to some of these software quality practices. It requires investment. Chances are you're going to have to make that investment sooner or later. It's just like anything else. The earlier you do it, the cheaper
right.
it's going to be.
Well, and that investment is often happening during the slow seasons and not during the peak season. So revenues are lower because it's not during peak season. So it's harder to convince uh, leadership to spend in those periods of time. But it's looking at that, looking at the long based approach, and saying, hey, if we don't do this and something goes wrong, it's going to cost us a lot more over time. So
And the more I think about it, it's almost like we're advocating for a shift left investing, practice, right? It's
right, yeah, yeah. Let's move that out of just developer speak and move that into leadership speak, right?
Right, right, right.
Great. This has all been such great information, and I so much appreciate your time and going through this. And I'm gonna kind of open it up here and see if we've got any questions that are coming in. And Yeah, just feel free to ask any questions, and we're just going to sit here for a few more minutes, and we're just going to chat a little bit more about different pieces. I know that we're working on a bunch of different things here at Parasoft. So all this that we're talking about today speaks very dearly to me, being mostly functional products. Um, Chaos engineering is such an interesting topic that I'm doing a lot of research into now. I've been seeing information about folks that are completely randomizing what fails in their infrastructure, um, and multiple pieces that'll fail randomly that nobody knows which ones it's going to be because it's not a scheduled failure, so that they can run multiple failures that no one would think of. So chaos engineering is a very, very interesting topic for me right now, for sure. Um,
You can also think about service virtualization as a very good segue into introducing chaos engineering into your environment, right? So if
mhm,
if you're already have an established practice of service virtualization, you can certainly start there. You can uh, mimic bad behavior or faults within the system by leveraging your existing services, by changing
right.
the way they behave, um, and sort of seeing how resilient and how your current system can actually handle that, and then introduce other things like chaos monkey or gremlin or any of those other chaos engineering tools.
Right. Well, and like with server virtualization, like forced failures on data. Like since you're virtualizing all the data, you can virtualize multiple variations of bad data and see how that runs through your systems for your testing. Um, so forcing failures is something that I've been seeing a lot of folks doing more of, um, so that they can see how their systems react when there is one. So
I think in general, you do also have to be careful about getting yourselves, you know, down the road where you're exploring unrealistic edge conditions. I
mhm,
think that is something to be aware of. If you're fixing things that, or you're spending time and money on fixing things that really aren't realistically possible,
Mhm.
that can obviously be a wasteful project. But overall, when you define that practice, when you invest aptly into your software quality practice, that's not going to happen, right? You're going to test realistic scenarios. You're going to be prepared for realistic scenarios, even though you've not considered those scenarios up front.
Right. Well, great. I think that about hits it for our time today. Thank you, everybody, for coming on out. I do have a couple slides here, or a couple of QR codes here for you to get information on. So, there's deliver with confidence for a continuous quality platform brochure that we have here at Parasoft. See how we did in the Forrester Wave. You can see the Forrester Wave automation testing platform information here for that one, and the value of virtualize. So one of the tools that we offer in this, we offer tools that cover most of what we were talking about today, except for the Chaos Monkey piece of it, but we pretty much cover the rest of it with things like our virtualized product and our SOA test product. And um, we have our load testing and a recorder and things like that. So feel free to hop out there, look at any of the different things that we want. If you'd like to get a demo on some of the services that we offer, we can get that set up for you as well. So if I don't see any more questions coming in here, we'll give it just a couple more minutes, and then we will thank everybody for their time. Gagore, I really appreciate this chat today. It's always eye opening talking to you. You've got such a wealth of knowledge um, in that brain of yours. You work on so many different proof of concepts and come up with ways to make things work that makes the rest of us go, where did that come from? So it's always amazing to talk to you about these things. I really appreciate your time today.
Well, likewise, and appreciate the opportunity as well. Always a pleasure.
Alrighty. Alrighty. Thank you, everybody. Have a great morning. And again, feel free to reach out if when you want to talk to us. Have a great day.